Hi, good morning, dear students. So, in the previous class, we learned about gravitation, and now in this class, we are going to learn something about work and energy. Okay, so before going to directly work and energy, first we will learn what is meant by force. So, in the previous chapter, we learned about force. Okay, force physical quantity which helps or which changes the velocity, which changes the shape of the object or which changes the direction of the object. Okay, force is a physical quantity which changes the velocity or speed of the object, which changes the shape of the object or which changes the direction of the object. For example, an object is moving in this direction. If you apply force from another direction, the object will change direction. So that means by the application of force, the object changes the direction. Or if a vehicle is moving and if we give acceleration, so its velocity changes. So that means we are applying an external force on the object. And if you consider mud pot, and if we apply force on that with a certain object, then it will break. It will break because of application of force. So similarly, your work is another term. So that is the effect of force. So when if consider an object and if we apply force on the object, it displaces. That means it changes the position from one point to another. For example, object is present here. I will call the object as A, and if I apply force on this object, the object will displace by a certain angle. So I will call this distance as S, or we can consider small letter s, or we can consider small letter d. D is the symbol used to represent distance. The symbol used to represent distance. So your work becomes work equals to force into distance, or we can consider work equals to force into displacement. So now comment me what is the SI unit of force. You learned in the previous class. So now comment me what is the SI unit of force. Just comment me fast. What is the SI unit of force? So the SI unit of force is Newton. We'll write that by using small letters, or we can use the capital letter. This is the SI unit of force. Now, when we consider the expression for distance, short forms, work is equals to force into distance. So, work expression, work SI unit I have to find out. Okay, this is the expression for work. Work equals to force into distance. Forces in Newton and distances in meter. So therefore, SI unit of work, we can write it as Newton meter. We can write directly the SI of work as Newton meter, because work is the product of force and distance. So by the application of force, if the object is displaced by that its initial position, then by multiplying that distance to the applied force we will get the work. So now in the textbook, so one problem is given, that is the example 11.1. Okay, we will solve that problem now. Just read that problem. So that is a force of 5 Newton is acting on an object. A force of 5 Newton is acting on an object. The object is displaced to 2 meter. In the direction of the force. If the force acts on the or through the displacement, then we have to find out the work. First I will write the given values. Okay, this is example 11.1. Example 11.1. First we have to write the given data. So what are the given data here? The application of force, its values here. Force, comma F, that is equals to 5. The next, the object is displaced through 2 meter. Therefore, displaced is this one. Displacement. I'll use small letter t to represent displacement, and that is equals to 2 meter. Now I have to find out the work. So therefore, work done equals to force into displacement. Work done is equals to force into displacement. So therefore work done becomes to force value is how much? That is 5 meter, and displacement value is 2 meter. Now commenting what is the total amount of work done in this exam along with the unit. Comment me the total work done along with the unit. Fast. And that is 5 to the 10 Newton meter, or we can write 10 joule. Okay, so directly we can use J, capital letter J, that is joule, small j u n as the SI of work. Okay, so work done is product of force and displacement, and by substituting the SI directly we get the SI of work done as Newton meter, or in general the Newton meter is known as joule. Therefore we can directly consider the SI of work done is joule. Okay, then example 11.2. Example 11.2. Example 11.1. Just read that question fast. Okay, again based on the work done, force and the distance, we have to solve this problem. A porter lifts a luggage of 15 kg from the ground and puts it on his head 1.5 meter above the ground. Calculate the work done by him on the luggage. So one porter is present, so he lifts that bag and keep that bag on his head, and the height of that porter is 1.5 meter from the ground, and the mass of the luggage, that is 15 kg. Now we have to find out the total work. Okay, first we write the given as mass. Okay, mass of the luggage, that is equals to how much? It is equals to 15 kg. Okay, mass of the luggage is given, that is 15 kg. Then here that porter lift that luggage on the head. Therefore, from the ground the distance is how much? That is 1.5 meter. That means we can consider the displacement. Initially the object is on the ground. Now that object is present 1.5 meter away from the original position in the upper direction. So therefore this height we can consider that as the distance, or the height we can consider that as the displacement of the object. Okay, therefore I consider this displacement we have to find out the work done. So I will write the expression for work done, that is work equals to force into displacement. Force into displacement. So now your displacement is given, that is 1.5 meter, but force value is not given. You have to find out what is the value of force. Okay, so here we know that F equals to mv. So that is according to Newton's second law. Acceleration given to a body is directly proportional to force, that applied force and the direction of the force, and it is inversely proportional to mass of the object. So by using the two statement, if we derive the expression, we will get F equals to m into a. So now in this case, the object is lifted, therefore instead of acceleration we have to consider the gravity. So m into g. So therefore work equals to force, that is mass, into gravity into distance. Just substitute the value and come into the answer. So for time being in this problem, for the simple calculation they consider the value of g as 10. So now you use 10 only. So but you have used accurate value, that is 9.8 meter per second square. You just substitute the mass is how much? It is 15 kg and gravity n into distance is 1.5. Just come and make the answer fast. Okay, all three values are in front of you. Mass is 15 kg, displacement is 1.5 meter, and for time being consider the gravity as 10 meter per second square. So therefore work done value is how much? Okay, therefore work equals to 15 kg, 10 into 1.5. So this decimal goes to the next place, so it becomes 15 is the 225 joule. So this is the answer for that problem. Okay, 225 joule is the answer. So this is about the work. So now when we go to the next concept, that is energy. So work and energy. So energy is the capacity to do work. Okay, by the application of force we are getting the work, and energy means it is capacity to do the work. Just note down the definition of energy. So energy means capacity to do work. Energy means capacity to do work is called energy. Next, SI unit. SI unit of energy. Okay, so SI unit of energy is dash. So in the previous class, you learned about the energy and its definition, expression, everything. Just comment me what is the SI unit of energy. Okay, we learned the SI unit of force as Newton, SI unit of work as Joule, SI unit of energy. And energy means it is capacity to do work. And now we have to use the SI unit. So what will be the SI unit of energy? Okay, here the SI unit of energy is again joule or capital energy, small Joule or capital energy. So that is again the joule is the SI unit of energy. So joule is the SI unit of work as well as joule is the SI unit of energy. So now when we talk about the energy, there are different forms of energy. For example, heat energy, chemical energy, kinetic energy, potential energy. So everything is dependent upon its nature. Okay, here mainly we are considering two types of energy. So that is kinetic energy and potential energy. Okay. So before going to that, we will learn about the conservation of energy. So that is conservation. Conservation of energy. So your conservation of energy means the energy can neither be created nor be destroyed, but it can change from one form to another. Energy can neither be created nor be destroyed, but it can change from one form to another. For example, when you switch on the bulb, so electricity is passing through the wire and reaches the bulb, and because of tungsten wire present in the bulb, so it glows. So when it glows, it spreads the light. So that means electrical energy is converted to light energy. And similarly, so after some time the bulb gets hot. So that means heat is also produced. So that means the electrical energy is converted into light energy as well as heat energy. There is no loss of energy. Okay, there is a fraction of loss due to the different resistance present in that, but we can consider that as very negligible. So only we have to think about the conversion. So your electrical energy is converted into light and heat. So now we'll see the different examples of how energy will convert from one form to another in the energy concept, that is by using the kinetic energy and potential. So here the conservation of energy means energy can neither be created nor be destroyed, but it can change from one form to another. Energy can neither be created nor be destroyed, but it can change from one form to another form. So when we look at the energy, so mainly two categories. First one is kinetic energy, and second one is potential. So just try to comment the definition of kinetic energy and potential energy. So what is meant by kinetic energy? Just comment me, as well as what is meant by potential energy. So now when we talk about the SI unit, it's coming fast, so I will continue the next concept. So when we talk about the SI unit, so the kinetic energy, so that is a part of energy. So therefore SI unit is joule or capital energy. Similarly, when we talk about potential energy, the SI unit is again, so SI unit of kinetic energy is joule, SI unit of potential energy is also joule. So when we talk about the definition of kinetic energy and potential energy, first one, kinetic energy. So the energy obtained by the object due to its motion. Energy obtained by the object due to its motion. For example, if an object is present at a constant place from a longer time, it does not have kinetic energy. So if an object is moving in a particular direction, or if an object is moving in a random direction, so then the object is in the state of motion. So when the object is in the state of motion, that means it contains kinetic energy. So here, therefore, the kinetic energy is the energy obtained by the object due to its motion. Energy obtained by the object due to its motion. Just note on the definition. The kinetic energy is energy obtained by the object due to its motion. the expression that is kinetic energy. So I will use short form. Okay, KE. KE means here kinetic energy. Okay, kinetic energy is half mv, half into mv square. Where half is a constant, m is mass of the object, and v is the velocity of the object. Okay, kinetic energy is half into mass into velocity square. It is half mv square. And again, as I told you that this side is joule or capital energy. So this is about kinetic energy, the energy obtained by the object due to its motion. So example for kinetic energy is a ball is moving in a particular direction, or a ball is kicked by an object and that ball is moving, or traveling, or a moving vehicle. They are all the examples for the kinetic energy. Next, about the potential energy. Next is about potential energy. So potential energy means the energy obtained by the object due to its position or deformation in its structure. Listen carefully. The potential energy means energy obtained by the object due to its position or deformation in its structure. Energy obtained by the object. Energy obtained by the object due to its position or deformation in its structure. Deformation. So here the first one is due to its position. That means the object is at a particular height. For example, mango present on the tree. So it has a particular height from the ground. Therefore, so that is the example for potential energy. And when we consider the second part, that is due to the deformation in structure. So deformation, change in structure. For example, if we consider a spring, so when we press from both sides, the side is shrink, that is compression. So that means change in the structure of that spring. So that gives the potential energy. Or when we pull the spring from both sides, it will expand. So that is rarefaction. So that is also change in the structure of the object. So therefore, because of position or because of deformation in structure, the object gains certain kind of energy, and that energy is considered as potential energy. Okay, therefore the potential energy is energy obtained by the object due to its position or deformation in its structure. And the expression for potential energy, so I use PT, so that it means potential energy, and that is the product of mass into gravity and height. That is the product of mass, gravity and height. M potential energy equals to m into g into h. And when we talk about the SI unit is joule or capital. Okay. The potential energy is energy obtained by the object due to its position or deformation in its structure, and the expression for potential energy is m into g into h, and the SI unit of potential energy is joule, okay, or capital letter J. So this is about work and energy. I'll continue in the next class. Thank you.